Hi, welcome back to Maths with Mr. Hammer. Now it can be extremely difficult to understand the unit circle way of doing trigonometry the first time you hear it. So to make things a lot easier, I'm going to do a whole bunch of examples all about using the unit circle definitions of trig. So this is going to be some unit circle examples in this video. Okay, so let's start off. Example 1. Asked to evaluate cos of pi on 4. So here we're dealing with pi on 4 radians. Okay, so what I'm going to do is I'm going to find where my pi on 4 is in a mini unit circle. So here's a unit circle, not a very perfect one, but you get the idea. Okay, so where is pi on 4 radians? Well, pi on 4 radians is, of course, the same thing as 45 degrees. So it is here. This angle here is pi on 4, or 45 degrees. So we notice in the first quadrant, and in the first quadrant, all of the trigonometric values, sine, cos, and tan, are all positive. They're all positive here. So all I've got to do is figure out what cos of pi on 4 is. Now, think back to my perfect triangles, and I can remember the one that's made out of a square to start off with. So there's a right angled triangle here, and remember that this is a square with side length 1, which gives this diagonal hypotenuse here a value of the square root of 2, and this angle is pi on 4. So cos is adjacent 1 over hypotenuse, which is root 2. So my answer is cos, let me just write my answer out, cos of pi on 4 equals 1 on root 2. There we go. Now let's do a second example, example 2. So once again we're going to evaluate. So find the answer to tan of 2 pi on 3. And we're going to follow the same sort of steps here. So first off, we'll start with a unit circle, and now we'll find where our 2 pi on 3 is. Now we know that this angle here is 180, to get it all the way around there, is 180 or pi. We also know that another way of writing pi is 3 pi on 3. But here we've only got 2 pi on 3. So we're almost at 3 pi on 3, but we're short by pi on 3. So angle is, this angle to go from here to there is 2 pi on 3, which leaves this bit here as pi on 3. So that angle there is pi on 3. So of course we know that that is, this is in the bit where only sine, this is quadrant 2, where sine is positive, and tan is of course negative. So if we dot this out this way, tangent line is of course going to be a negative value around here somewhere. So the equivalent angle now is if we put that over in this way, and this bit also with pi on 3. That's how we find it. So tan of 2 pi on 3 is the same as, let me start again. It's not sine, so it's negative tan of pi on 3. So what is tan pi on 3? Well, we can use our other perfect triangle at this point. Our other one, we remember, started off being an equilateral triangle. So with side lengths of 2, it's been cut in half though. So this length is 1, this is root 3. Here we've got pi on 6 up here in this corner. Here we've got pi on 3 in that corner. So here we've got tan of pi on 3. Tan of pi on 3 is opposite root 3 over 1. So is negative opposite over adjacent equals negative root 3, the opposite over adjacent 1. So that's just negative root 3. So to put our final answer down, I can say that tan of 2 pi on 3 is equal to negative root 3. So our final answer. So there we go, example 2. Let's keep going with another example. Example 3. So we're going to evaluate again tan 7 pi on 6. And we're going to follow the same procedure. We're going to identify 7 pi on 6, where that is in our unit circle. So 7 pi on 6 is slightly greater than pi radians, greater by, so it's greater than pi radians, and this angle here, bit that's greater by, is of course pi on 6. So it's greater than pi by pi on 6. Now if we would draw the equivalent one here, that would be pi on 6 there. Pi on 6. Now the third quadrant, this is quadrant 3, and that is the quadrant in which tan is positive. So tan of 7 pi on 6 is equal to tan of pi on 6. So now we've got to find out what tan of pi on 6 is. So we can once again get out our perfect triangle. 1 to root 3. Pi on 6 is this angle up here, the small angle. Pi on 6. So tan is 1 on root 3. 1 on root 3. There we go. Okay, so another example, example 4. Example 4, we want to evaluate sine 5 pi on 3. That's a 5. Okay, same sort of idea. Draw a bad unit circle. My unit circles seem to be getting worse, but you get the idea. So this is just to help my brain think a little bit. So 5 pi on 3 is almost 2 pi. Because another way of writing, so 2 pi is a full circle. Another way of writing 2 pi is, of course, 6 pi on 3. So here our denominator is 3. So it's not quite 6 pi on 3, it's only 5 pi on 3. So it is pi on 3 short of a full circle. So of course that's symmetrical like in this way here. Like that's the sort of symmetry we've got here, where this bit is pi on 3. And this of course is the cos quadrant. Quadrant 4 only has cosine of being positive, so sine is negative here. So this must be negative sine pi on 3. Now we can use the same perfect triangle that we had before, this one here, because we know this angle is pi on 3. Sine, so that's negative. Sine is, of course, opposite, root 3 over hypotenuse, root 3 over 2. So our final answer is sine of 5 pi on 3 equals negative root 3 on 2. Okay, excellent. Now we're up to our second type of example. So new sort of type of example. So we're up to example 5, which is a new type. So here, solve for theta for the angle of sine of theta, the angle, equals -1. Okay, so here I'm going to take out my unit circle again. 1, 1, -1, -1. Now I've got to remember that, of course, the x-coordinate is cosine of theta, and the y-coordinate is sine of theta, just like we learned in our previous video. So here we're looking for sine of theta equals -1. So we're looking for where does y equal -1. Now the only point around this whole circle where y equals -1 is right here. It's the only point. So we're looking for this angle here. And that angle there, of course, is 270 degrees, or better in radians, so it's 270 degrees, or better is radians, so that is 3 pi on 2 radians. So our answer is, the angle is 3 pi on 2. Now you've got to watch out here because it doesn't say what the angle can lie between. Because there is another solution. What if we start here and we go all the way around and then keep going around till here. In other words, we've done one loop and then done another 270 degrees. In other words, our next answer is 2 pi plus 3 pi on 2. So this bit here, 2 pi is the same as, so 2 pi, let me just write this here, 2 pi is the same as 4 pi on 2. So when you add that 3, that's 7 pi on 2 for this bit here. So then you can actually do another loop if you want to. So there'll be another one which is 4 pi plus 3 pi on 2. And that bit there, of course, for 4 pi is 8 pi on 2. So plus another 3, that's 11 pi on 2. And you can keep going if you'd like to and get more and more. There's also some other solutions if you go backwards. So this angle going this way is a negative angle. So going back to here, that's negative pi on 2. So there's another answer which is negative pi on 2. You can also go backwards but do a whole loop and then that bit. In other words, that one is negative 2 pi minus pi on 2. So this answer here, of course, negative 2 pi. So negative 2 pi is negative 4 pi on 2. So that would be negative 5 pi on 2. If you keep going that way. And you can see that this is just going to continue in both directions forever. Okay, so there's a very interesting example where we've got an infinite amount of solutions. So this one has infinite solutions. Infinite solutions for that particular example, which is interesting and a little bit annoying sometimes. Okay, next example, example 5. So solve cos theta equals 1 on root 3. Here though, we're going to say that the angle has to lie between 0 and 2 pi. Okay, so here we're not going to have infinite solutions because our answer has to be between 0 and 2 pi radians. Okay, so let's do this in a similar way to before. Here, let's imagine here that we were just doing a normal question with a right angled triangle. Okay, so we've just got a standard old right angled triangle. Cosine is, of course, this will be our 1 over root 3 will be 1 for the adjacent side, root 3 for the hypotenuse there. So what you can do is first we need to find the angle. So to find the angle, that is doing the angle is of course the inverse of cos of 1 on root 3. So this bit you might want to do on a calculator. So let's quickly grab out our calculator. So we're doing trig, we're doing the inverse cosine of, let's do a fraction thing, 1 on root 3, so square root of 3 is what we're doing. And okay, let's get an approximate answer perhaps. There we go, 0.955. Okay, so our approximate answer was 0.955 and so on and so forth, more decimal points after that. So we've got our angle for one of these. So here, let's now think about the unit circle. So this angle we've just found here is actually in the, that's in radians by the way. Our angle 0.955, that's in radians, see. Okay. So we have, we've found this angle here. Now, of course, here we've assumed that this is in quadrant 1 for this particular angle, where everything is positive. So we've assumed that everything's positive to do our circle. We found the first quadrant solution. But there's another time at which cosine of the angle is 1 on root 3, and the other time when cos is positive is in this quadrant number 4 here. Quadrant number 4, cosine is positive, and that's where this angle here is the same. So this angle is 0.955, and this one is the same angle as well. Okay, because this quadrant 4 is the cosine angle. So here, this angle here is actually has to start here and go all the way around, which is the same as 2 pi, because 2 pi is the full thing, minus our answer. So in other words, that is 2 pi minus 0.955. And we can put that into a calculator to get a purely decimal answer if we like. Now there would be another answer if we started here, went the whole way around the circle, and then went back along here. But now that whatever that answer is now bigger. That new answer would be 2 pi plus 0.955. But this answer is larger than 2 pi, so it's not in our domain here. So there's only two solutions. This one, our first quadrant solution, and this one here, our quadrant 4 solution. So to write our answer, we can write theta equals 0.955 and 2 pi minus 0.955. And there we go, so we've got two solutions. Okay, let's move on to our next example. I might do another similar one to this to help you understand it. Okay, example 6. Okay, solve tan theta equals 1. So the first thing we want to do is find out what the first quadrant solution for this is. So let me draw a unit circle in preparation. Okay, so tan of the angle is going to be 1. So if there's a triangle in the first quadrant, we're trying to find this first quadrant answer here. So we're going to do the inverse tan of 1 to find our angle. So let's do that on the calculator. So let's grab our calculator page. Alright, inverse tan of 1. There we go, it's pi on 4 is our answer, pi on 4. So angle is pi on 4. So here we've got pi on 4. Now we've got to think, oh, by the way, I should have really written the bounds, shouldn't I? So let's get answers between 0 and 2 pi. There we go. So our solution has to be within this domain here. Okay, so where's the other point at which tan also equals positive 1? Well, the other point at which it equals positive 1 is in this third quadrant. It's the tan quadrant, where this angle here is the same. So that angle is pi on 4 as well. So to get the proper angle, we have to start here at 0 and go all the way around. So at this point is pi. So to get it a little bit more is pi plus pi on 4. Pi plus pi on 4, which of course equals 4 pi on 4 plus pi on 4, which is 5 pi on 4. And there's nowhere else within our bounds at which tan of theta is 1. So we can now write our final solution is that theta equals either pi on 4 or 5 pi on 4. There we go, let's do another example. Okay, this one's an interesting one. We've got solve sine of theta equals negative a half, and we'll have the same bounds as well. So theta must be between 0 and 2 pi. So remember, it can equal 0, it can't equal 2 pi. All right, so let's find. Let's have a think about this. Okay, let's draw a unit circle to help us think about this one. Okay, so where can sine be negative? Well, sine can be negative. This is all of them are positive here. Sine's positive in second quadrant. In the third quadrant, only tan is positive, and in the fourth quadrant, only cosine is positive. So the places where sine is negative are in the third quadrant and the fourth quadrant. So our angle must be somewhere in here and then somewhere in there where this bit here and this bit here must be the same. That bit and that bit must be the same. Now to find the equivalent bit in the first quadrant, whoops, that was a bit bad, must be this angle here, this angle there. Okay, so let's pretend for a moment that we were looking for this first quadrant equivalent bit. Okay, so if we pretend that it's positive for a moment, we can find that, so let's just say, imagine we had sine of x being equal to a half. Now we can say that x is equal to the inverse sine of a half. So let's do that on the calculator. Inverse sine of half, 0.5. It's actually, I guess if you put a decimal thing in, you get a decimal output. So I'm going to put in sine, inverse sine of half as a fraction. We get out pi on 6. So it's pi on 6. X equals pi on 6. So this first quadrant angle here is pi on 6. But we're not looking for that because that is when this is negative. So to get our solutions to make this negative, this bit here is pi on 6, pi on 6. In other words, to get the proper angle that we're looking for, it is pi plus pi on 6. Or this one here, if this bit is pi on 6, to get all the way around to that, it's the same as doing a whole loop minus this bit. In other words, it's 2 pi minus pi on 6. So this one, pi plus pi on 6, is the same as 6 pi on 6 plus pi on 6, which then equals 7 pi on 6. This one here, well, 2 pi is the same as 12 pi on 6. Take away pi on 6 is 11 pi on 6. So these must be our two angles for theta, because here, quadrant 3, quadrant 4, sine angle is negative. So our answer is therefore 7 pi on 6 and 11 pi on 6. And this is due to symmetry. Okay, so hopefully those examples have helped you out. Alright, let me do just one more example for you. Let's get a bit of space. Alright, one more example. Let's do, let's solve sine of theta equals 1 on root 2. And for this one, I'm going to tell you that the bounds are between negative pi, not including negative pi, and let's make life a little bit interesting. Let's say 4 pi. Okay, so this might be an interesting example. Let me also change this sine of theta equals, let me make it negative 1 on root 2. So I'm making it a little bit harder. Okay, so first off, I want to find, let's do a triangle here. Let's do x. So what I want to do is find x for sine of x equals positive 1 on root 2. So x is inverse sine of 1 on root 2. So let's find that. Inverse sine of 1 on root 2. Inverse sine, do it in fraction form, 1 on root 2. There we go. It's pi on 4 is the answer. And we could have used a perfect triangle if we wanted to. We could have used the 1 root 2 pi on 4 triangle to find that out if you had wanted to. Have that in the back of your mind. Anyway, x is pi on 4. So the first quadrant equivalent is pi on 4. But here, sine of theta is negative again. So let's draw this out on a unit circle. So because it's sine, the places where sine is negative is over here in the third quadrant because it's the tan, and over here in the fourth because it's cosine. And our angle's pi on 4, so we're going to have it a bit like this, where this bit here is pi on 4. And another bit like this, where this angle here is pi on 4 as well. Okay, so let's list a whole bunch of different possibilities, and then we'll keep going until we've got ones that are no longer within the bounds. So let me explain that. So let's go. If we're looking, let's first look at the positive ones. So for this one here, this pi on 4 angle here, well, starting from positive x-axis all the way around is pi plus pi on 4. Pi plus pi on 4. So our first answer, theta equals, our first one, this one here, is 5 pi on 4. Our second one is this one here, which is 2 pi minus pi on 4. So that is 7 pi on 4. Now if we keep going, so we've done a full lap and then back to this one, it's going to be 2 pi plus this. So that's like 8 pi on 4 plus 5 pi on 4. So that's going to be 13 pi on 4. And then the next one is if we went around it a whole time and then back to this point here. So that's like 4 pi on 4 pi, take away pi on 4. So that would be 15 pi on 4. Then the next one is if we did 1, 2 full laps and then back to here. So we've done 4 pi. We've done 4 pi plus 5 pi on 4. 4 pi plus the first one. So that is the same thing as doing 4 and 4, 16 pi on 4 plus 5 pi on 4, which is of course 21 pi on 4. So the next one's 21 pi on 4, and then the next one's going to be 23 pi on 4, running out of space as you can see, and so on and so forth. Now notice we're only going up to 4 pi here. So 15 pi on 4 is smaller than 4 pi, but 21 pi on 4 is larger. So we've got to not include those last two because they are not in our domain. Okay, now we're going to go backwards. So in negative angles, if we start off going that way, we've got negative pi on 4. Then if we keep going backwards to this one, that's negative 3 pi on 4. Then if we keep going backwards, we'd have to do a whole backwards loop and a little bit more. So that's like doing negative 2 pi minus pi on 4. So what we've got here is negative 2 pi is negative 8 pi on 4 minus another pi on 4. That is negative 9 pi on 4. So the next one is negative 9 pi on 4. But once again, negative 9 pi on 4 is outside of our bounds, so that one doesn't count. These all do count though. So we've got 1, 2, 3, 4, 5, 6 solutions. 6 solutions. 6 solutions there. So we have to keep going until we've got all the solutions, and the way to check to see if we've got all of them is to do one extra on both sides, the negative side and the positive side. Do one on both sides. That way, so one on both sides that isn't in our domain, then you're confident that you've got all the ones that possibly are in the domain. Okay, so that's it. Thanks for sticking through these examples. Please refer to them again if you get stuck, and I'll see you in class.